sac212 problem number 3. We want to find the voltage across and the current through each of the resistors in this circuit. Start by identifying the low side and the high side of the seats of EMF. The short side is the low side. The long side of the symbol used to represent the seat of EMF is the high side. Now define a couple of currents. Call this I1. When it gets to this point, there's a branch off. I'll have I1 going down. I2, I'll call that. And in this leg, I'm actually going to have the current going this way. The way this seat of EMF would tend to push charges around. We'll call that I3 since it goes through R3. So you got two currents coming into this junction that join together, form I2, and then they come out here. I3 goes out, I1 comes back out there. Based on the current directions, I can now identify the high side and the low side of the resistors. The current always enters the high side and exits the low side. So I2 comes in here, that makes that the high side, and this the low side. Over here for this resistor, I3 comes through in this direction. That'll be the high side and the low side. I'm going to call the voltage across resistor R2 V2. Voltage across R1 I'll call V1. And the voltage across R3 I'll call V3. Now we'll identify some loops and junctions. Draw a loop in this part of the circuit. Call that loop number 1. Over here, it goes all the way through, comes right back to where I started. Always goes all the way back to the start point. I'll call that loop number 2. Make a junction up here. I'll call that junction A. Start applying Kirchhoff's laws. Kirchhoff's voltage law, the loop rule, on loop 1 yields, say I got a minus V1 as I go around that loop, and then minus V2. Since I'm going from the high side of the resistor to the low side as I take this imaginary traversal of the loop, and then plus V1. And then, because I'm back to the start, equals 0. I'll go ahead and use Ohm's law to replace those voltages with currents. V is equal to IR, so V1 is I1 R1. And V2 is I2 R2. Still got the E1 there. Let's try KVL on another loop. Loop number 2. I'm going, as I traverse the loop, make this imaginary traversal. I go from low to high across R2, so that's a change of plus V2. And then from high to low here, I change a minus E2, and then plus V3. Or replacing the voltages with IRs, I2 R2 minus script E2 plus I3 R3 equals 0. And then the current law at junction A, total current in is equal to 0, so I got I1 coming in. This arrow is labeled I2 here. and it's leaving, so that's a minus I2 in to junction A. The count current that's leaving junction A is the negative of that amount of current coming into it, and then I got plus I3 is coming into A. That's all I got to be equal to 0. So now I got to solve this set of 3 equations. This guy, this one, and this one for one of the currents. They've all got currents in it. Notice I like to treat this one as the equation that I'm going to solve, and I'll substitute currents for that until I get it down to just one equation with one unknown. I notice that this has got an I2 and an I3, an I1 and an I2. This has all 3 of them. I2 is in every single one, in every single equation. So I'll try to get this just in terms of I2. Can do that by solving this equation for I1, substitute it into there. Solve this one for I3, substitute it into there, and then this equation will just have the one unknown, namely I2. So let's go for that. I'll get started by adding I1 R1 to both sides, and rewrite the left. I'm switching sides at the same time, so I got E1 minus I2 R2 left. This yields for I1, if I divide both sides by R1, I get I1 is equal to E1 over R1 minus, divided by R2 in this term, gives me R2 over R1 times I2. And then this one I want to solve for I3. I'll leave the I3 R3 over here on the left. Add E2 to both sides. Subtract I2 R2 from both sides. Then divide both sides by R3, yielding I3 is equal to E2 over R3 minus R2 over R3 times I2. So I'll take this equation and this equation, substitute in here for the I3, substitute this one in here for the I1, and I got an equation just in I2. So that'll read E1 over R1 minus R2 over R1 I2. Okay, that's the I1. And then minus I2 and plus I3, which is this expression. And all equal to 0. So I'm just going to solve that now for I2. I think I'm going to write down, I'm going to add everything that's got an I2 in it to both sides. So on the right, in this equation, I'll have R2 over R1 times I2 plus I2 plus R2 over R3 I2, and then I am switching sides. I'll write the right hand side of that equation over here and the left on the right. That's got an E1 over R1 plus E2 over R2. Now I just have to factor out the I2. and divide both sides by this expression in parentheses. I think I want to get rid of the fractions first. I'm going to multiply both sides and I made a copy error up here. This is an R3. E2 over R3. Going to multiply both sides by R1, R3 to get rid of these denominators. R1, R3 times the entire equation. So it's got to be multiplying every single term. That'll give me R2, R3 here, plus R1, R3, plus R1, R2, all times the I2, equals R3, E1, plus R1, E2. And now I'll go ahead and divide both sides by this thing in the parentheses to give me my answer for I2. All divided by R2, R3, plus R1, R3, plus R1, R2. And that's one of the answers. That's the current through resistor R2 in the direction that I've indicated it as going, that is left to right. To get V2, I just use V1, I just use Ohm's law. Let me rephrase that. That's this current right here, I2, the current through R2 from top to bottom. Okay, now I get V2 using Ohm's law. V2 is equal to I2 R2. So that's this whole expression. Times R2. That's my answer for V2. Okay, then I want to get I1, the current through resistor R1. That's I1 right there is the current through R1, and we had an expression for it. We solved for it. It's right there, E1 over R1 minus R2 over R1 I2. In terms of I2, which is now known. So E1 over R1 minus R2 over R1 I2. So I1 is E1 over R1 minus R2 over R1 times what we just found for I2. That's our answer for I1. And V1 is just I1 R1. So we just have to multiply this expression by R1. And I'll simplify that one a little bit. V1 is equal to, I got an R1 in the denominator of both terms. So that'll be E1 minus R3 E1 plus R1 E2. And take this piece. And then times the R2. I still got left there. So there's V1. I got the current through resistor 1, voltage across resistor 1. Same thing for 2. Now I just have to get 3. Let's start with I3 is equal to, we did find an expression for that while we were solving along, script E2 over R3 minus R2 over R3 I2. So that's E2 over R3 minus R2 over R3 times what we got for I2, which is this expression right in here. Just used it, so I'll copy it down from there where I can see it. That's our answer for I3. And then multiply that by R3 to get V3 that's E1 plus R1 E2 R1 I gotta multiply that whole thing by R3. And I'll go ahead and simplify that. Since I got an R3 in the denominator in both places, I'll distribute it. So V3 is E2, I got it right, minus, and I'll put the R2 on the other side, R3 script E1 plus R1 E2, all divided by R2, R3 plus R1, R3 plus R1, R2, all times R2 out here. And that's our expression for V3. Voltage across resistor R3, and that does it for problem